Welcome to our video on correction images in image preparation. I've brought along an image that someone very kindly provided for me. It's a picture of a galaxy, so astrophotography. The reason we're using it is that the effect of these correction images is really clear in these kinds of picture. And I want to show you something here. We have a group of 4 stars up here. And if we zoom in a bit and turn off interpolation, we can see there's a red dot in here. This red dot is called a hot pixel. This hot pixel is a misinterpretation by the camera sensor of the brightness and color at this spot. And to correct that, we use what we call a dark frame or dark noise shot. Let's see what one looks like. And these pictures are taken with the aperture closed. So we ensure that no light reaches the sensor in the camera and take a picture more or less in complete darkness. And if the sensor had recorded it correctly, this image would be completely black. Any color deviations we see here, red, green, blue, different colors, sometimes mixed, are misinterpretations by the camera sensor. And this happens with every camera. It's stronger in some cameras and weaker in others, but it's there in all of them. These hot pixels can be removed or reduced through dark frame correction. And we do that in image preparation by activating the correction images up here. We activate that. Then we can enter a dark frame or an image taken with the aperture closed. We just choose it here. And the important thing for the calculation or correction is that this dark frame has exactly the same resolution in pixels as the image being loaded. We want these sensor hot pixels to be overlaid and calculated precisely. If the resolution doesn't match the loaded image, the program automatically skips the calculation. So to avoid an incorrect calculation, it's not performed. Let's go back to this red pixel, this hot pixel, and reload the image. Now with the correction using the dark frame, we have to zoom in again and we can see below our 4 stars from last time, there's no longer a red pixel. Instead, it just looks like the rest of the picture, which is as it should be. In this way, we can remove these hot pixels from the image and basically improve the quality of our camera. There's a second correction option, which is called flat frames. Let's see what that one looks like. This is an image of a neutral grey surface. This is normally what it should look like if we take a picture of a completely uniform surface. We should get a uniform image, but here we can see slight differences in color. We can see sensor spots, maybe small oil spots on the sensor or spots on the lens. And we can see the images get darker towards the edges. This is known as peripheral light shading. And these lens distortions in light, these errors, peripheral light shading, can also be corrected using this flat frame. And we can also add that here in image preparation. So it's added automatically when we load the image. Now both images are set. For flat frame 2, the resolution needs to be the exact same. If it doesn't match, the function skipped. Let's load the image a third time, our galaxy shot. Now with correction using both dark frame and flat frame. We then get a very homogeneous image overall. The peripheral light shading is gone, the sensor errors are gone, and our hot pixels are gone. So we have ultimately improved our camera technology. If we now develop the image a bit, here I have a preset I made called Astro. We get a nice homogeneous and consistent development. And this dark frame and flat frame technique can be applied to any image. It's not limited to astrophotography. It works for any shot, hot pixel removal, peripheral light shading, automatic brightness correction for sensor spots or fingerprints on the lens. I hope you found that helpful. See you next time.